Okay, so here's a little example of how we're going to solve a problem with friction. All right, so for now, again, remember everything is just going to have balanced forces. All right, because it says a man is pushing a 2-kilogram broom at a constant speed across the floor. The broom handle makes a 50-degree angle with the floor. He pushes the broom with a 5-Newton force. What is the coefficient of kinetic friction? All right, so first we'll draw a force diagram of the broom. Okay, so I'm going to have my FG broom earth down. All right, if you want to add the feeler dealers. The man is sort of pushing in this direction, FN broom man. Okay, the ground is pushing up, all right, and since I've done a lot of these problems, I can see that if the man is pushing down into the floor also along with the weight of the broom, this is going to have to be a little higher. Okay, so that's the normal force on the broom from the ground. All right, and then there's going to be some amount of FF broom ground. Okay, all right, I'm going to set my direction up this way because he's moving to the right, it looks like. All right, and first thing I want to do before I even bother to do anything is I need to split this force. All right, so I'm going to have this force kind of this way, Fn. I'm going to go ahead and call this Fn. Well, I'm just going to call it Fn, okay? And then I'll call the other one something else. All right, so Fn, so I'm going to have this Fnx, okay, and this Fny, right? Because that's how he's pushing kind of to the right and down. And it says it makes a 50-degree angle with the floor, okay? So in the picture, you know, the broom is over here. I would kind of think of this one as being the 50, okay? But if it's with the floor, then that one's also going to be the 50, all right? So I'm looking at a triangle that looks like this. Here's my Fn, Fnx, Fny, and that's my 50. Okay, down, down. So my Fnx is going to be Fn cosine 50. Okay, and then my Fny is going to be Fn sine 50. All right, and we know that he's pushing with 5 newtons of force. Okay, so just to make things a little bit easier, I'm just going to go ahead and make that calculation right here, okay? Sometimes you're not going to be able to do that, right, because you don't know the number. Okay, so that's going to be 3.2, and then this is going to be 5 newtons sine of 50. Make sure you're in degrees. It's going to be 3.8. Okay, all right. So once I do that, I'm going to redraw the picture, okay, because you need to do that, all right? And then I'm going to go ahead and I'm just going to clean up these labels a little bit so that I can make sure that I don't get confused later, okay? So I'm going to have my Fn down, my Fg down. Okay, and then I also have down with this one I'm going to call Fny. Okay, and then this way I'm going to have Fnx. This way I'm going to have Ff. And this way, I'm going to have force of the normal. I'm just going to put a G, I guess, maybe for ground. I don't know if that's the best way to do it. Or maybe I'll just put a 1. 1, maybe I'll call this one 2. Okay, see, right? Because I just need to make sure that can track those because these are different forces. Okay, so you have to make sure that the FNs are not the same. All right, I can see this doesn't look balanced. All right, so I'm going to make this one a little bit bigger. Okay, so I'm going to go ahead and call this one now Fn2, this one Fn1. All right. Okay, then I'm just going to sum the forces in the x equals 0, and I'm going to sum the forces in the y equal to 0. Okay, equal to 0 because this is moving at a constant speed. That means the forces are balanced, the net force is 0. That's it, okay? Notice I don't even care what I'm solving for yet, right? Like, it doesn't even matter what the actual question is. You're still going to go through this entire process every time. It does not matter what the question is, okay? I'll just worry about that later, all right? Okay, so I said this way is positive, so I'm going to go Fn2x minus the force of friction equals 0, okay? And then on this side, Fn1 is up minus Fg minus Fn2y equals 0. Okay, so notice I had minus, because both of those are facing down. Okay, all right, now I have to try to figure out what I'm looking for. So I'm looking for mu, the coefficient of friction. All right, and the only thing I know that has mu in it is this equation. Okay, force of friction equals mu times the normal force. All right, So if I want mu, I'm going to need, oops, FF and FN, okay? And it's actually FN1, right? Because it's this one that I care about, the one that's with the ground. That's the one that I'm talking about, okay? Right, so I'm going to need that. So I can see that I'm going to need FF and FN1 to get the mu, okay? So over here, FN2x, okay, that was convenient because I already solved for that up here, which was 3.2 newtons, okay? And then over here, this is the one I want, so I'm just going to reorganize. Okay, FG, I think the broom was 2 kilograms. Okay, so I'm just going to call that 20 newtons. Okay, 20 newtons plus FN2Y was 3.8. So that's 23.8 newtons. Okay. All right, so now I know both of these. Now I can come down here. Mu is the force of friction over the normal force, 3.2 newtons, 23.8, 0.2 divided by 23.8, and I get 0.13, okay, which seems like a very reasonable amount. It's a pretty small amount of friction. I wouldn't expect there to be too much friction between the floor and the broom, right? Those surfaces probably would generate a pretty small mu, okay? All right, so that's how you'd solve that. So it doesn't really matter what you're solving for, right? You're going to still draw your force diagram, okay? Split your components. If you have numbers, you can use them. If not, leave in variables. Redraw. Don't skip this step, okay? Sum the forces in both directions equal to 0. Then try to figure out what you need to find, okay? If you follow that process every single time, right, and you get down to these equations, then you'll be golden.